In order to write noble gas electron configurations, we need to look at the periodic table and how it's set up in terms of blocks. Alkali metals and alkaline earth metals make up the S block, S being the sublevel, the spherical shaped orbital. Remember, there are 2 electrons that fit in the S orbital. So alkaline metals, it would be S1, alkaline earth metals, S2. The P block, if you skip the transition metals, is to the right side of the periodic table. Remember, there are 3 orbitals that each take 2 electrons, so each element represents one of those electrons. In the middle, you have the D block. There are 10 elements, and again, 5 orbitals. And then on the bottom is the F block, and there are 14 elements, which fit into 7 orbitals. So the noble gas configuration is a shortcut way of doing an electron configuration. So if we look at the electron configuration of germanium, for example, germanium is on the 4th row. So it's going to end in 4p, and there's 1, 2. So that's going to be the very last part of germanium. So we start at the beginning, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. And if we added up those electrons, the exponents, it should equal 32. Now the shortcut way is doing the noble gas electron configuration. So you look at the noble gas above germanium, and remember group 18 are the noble gases. And instead of writing the noble gas for argon, you're going to take argon's electron configuration and just let the symbol AR represent that electron configuration. And so instead of this, we will put AR, and then you'll go on to the 4th row or the 4th period, and the first block is S, 4s2, and then this is 3d, this is 4d, 5d. Because remember, the D's do not actually start with the 4th row. 4s comes before 3d, so the first D period is going to be the 3rd, n equals 3. So 4s2, 3d10, 4p2. So one of your classwork examples is to figure out the electron configuration of iron. So again, you're going to look at the noble gas above it, and it's going to be AR, so this is the one for iron, and 4s2, 3d, 1, 2, 3, 4, 5, 6. And you just count across from left to right to figure that out.